Hi everyone, welcome to the Earth Science Regents Review podcast series created by the Moon-Hommocks Middle School Earth Science Department. Today we're going to be talking about the moon. The moon formed during an episode called the Big Whack. The Big Whack was an episode that occurred about 4.5 billion years ago during the formation of the Earth. As the Earth was forming, a large object in space crashed into the Earth and knocked a section of the Earth off, which eventually formed into our own moon. We can make that inference because the moon and the Earth are made up of the same type of rock called basalt. The moon is also our only natural satellite as well. Big thing about the moon is that it has two motions, rotation and revolution. The thing that's important here is that rotation and revolution occur at the same rate with the moon, which means that we always see the same side of the moon. We always see the near side. We never see the back side or the far side of the moon. One complete revolution is what we call the sidereal month. Occurs about 27.5 days. That's going to be one revolution around the Earth. That's going to be a little bit different from a complete cycle of phases, which we'll talk about in a little bit. Now, just like the sun, sometimes the sun's close to us, sometimes the sun's far away from us. When the moon is close, we call it perigee. When the moon is far, we call it apogee. Just like with the sun, it's perihelion and aphelion, the moon exhibits the same change in distance as well. And the reason for that, the moon has an elliptical orbit around the Earth. The moon rises and sets about 50 minutes later each day or each night, depending on the phase that you're in. So if the moon rises tonight at, say, 7 o'clock, it's going to rise tomorrow at 7:50, the next night at 8:40, the next night at 9:30, and so on. So the left-hand picture, that is apogee, A away. The moon is smaller, means it's farther away. You see that the moon on the right-hand side is a little bit bigger, means it must be a little bit closer. That's perigee. So our phases are going to be important here because this is going to be the amount of light reflected back to our eyes based upon the moon's position in relation to the sun. So this is going to be caused all by the revolution of the moon around the Earth. And what's going to happen here is based upon the amount of sunlight reflected back to us, the moon is going to appear to change shape in the daytime or nighttime sky. Now, one complete cycle of phases from new moon to new moon is what we call the synodic month. Technically 29.5 days. But on your regents, you'll see a lot of times that'll be rounded up to about a month or about 30 days. Now, this diagram here shows the sun's rays coming in from the right. You need to be able to find the phase in between the Earth and the sun. Once you figure that phase out, that's what we call our new moon. You go counterclockwise around the Earth. What's going to happen here is that each phase is going to be about 3.5 days difference. So from 1 to 2, 2 to 3, 3 to 4, and so on, each change in phase is going to be about 3.5 days. So it's very easy to figure out how much time goes by. If you're asked to go, say, from stage 1 to stage 3, that's going to be about 7 days or about a week. Stage 1 to stage 5. That's going to be about 2 weeks or about 14 days. Stage 1 to stage 7, that's going to be about 3 weeks and so on. So it's very important to be able to figure out the amount of time that goes by. So our new moon, you can't see because it's out during the daytime. Next is going to be your waxing crescent. You know you're going to go your waxing crescent second because you are going to go counterclockwise around the Earth. You'll notice that your waxing phases get brighter from right to left across the surface. Phase 3 is going to be your first quarter. Phase 4 is going to be your waxing gibbous. Phase 5, about 2 weeks into your revolution, is going to be the full moon. Once you get done with the full moon, now the phases start getting darker from right to left across. That's going to be your waning gibbous, your third quarter, your waning crescent. So once you get your phases down, now you can start talking about eclipses. A lunar eclipse is going to occur during the full moon, and this is going to be an eclipse of the moon. The moon is going to pass into the Earth's shadow, much like what you see in this diagram here. Now, this diagram is not drawn to scale, but you see the full moon is fully engulfed into the Earth's shadow. That is what we call a lunar eclipse. Eclipse of the moon happens during a full moon. Solar eclipse is exactly opposite. This is an eclipse of the sun, which occurs during the new moon. So this has to happen during the daytime. So you see the new moon moves in front of the sun and blocks out and creates a shadow on the Earth. Now, this is kind of odd because the moon, even though it's significantly closer to the Earth, it's significantly smaller than the sun. So the sun and the moon are exactly the same size in the daytime sky. And that's just an astronomical coincidence. Okay, even though the sun is much larger, it's just further away. So they appear to be exactly the same size in the daytime sky. The moon will slide completely over top of the moon, over top of the sun. Excuse me. The reason why this doesn't happen every single month is because the moon's orbit is tilted 5 degrees above our orbit or 5 degrees below our orbit. So the tilt of the orbit has to line up with Earth in order for an eclipse to actually occur. Next leads us to tides, which are also cyclic. They happen over and over and over again, actually on a much more frequent basis than your phases. You tend to get 2 high tides and 2 low tides every 24 hours. So there's a couple ways in which you can look at this time frame. You can say that your high tide to low tide is 6 hours apiece. You can say from high tide to high tide is 12 hours apiece. From low tide to low tide is 12 hours apiece. So you definitely need to know how many high tides and how many low tides you get in a single 24-hour period. Now, there's 2 different types of tides you need to know. You need to know your spring tide, which can occur at your new and full moon. Okay, what's going to happen here is that the gravitational pull of the moon and the sun, specifically more the moon because it's closer to us, is going to pull on the liquid part of our Earth. And what's going to happen is you're going to get high tides and low tides. But during a spring tide, you get really, really high tides and really, really low tides. Very simply because the Earth, moon, and sun are all lined up. So you can see in this diagram, you see the new moon and the full moon. Those are going to be the 2 phases in which you are going to get your spring tides. And you notice the letter H's representing your high tides. They're completely in line with your moon. So new moon and full moon. You compare that with what are called neap tides, which are going to occur at first and third quarters. Now these are going to be a little bit more adjusted tides. So you're going to have a little bit lower high tides, but a little bit higher low tides. So there's not going to be as much of a difference in water level between your tides. So you'll see here between first quarter and third quarter, notice the letter H's are directly in line with the moon again. Again, this time the reason why your tides aren't as extreme because your moon and the sun, they're somewhat right angles to the Earth. So they're not going to be nearly as exaggerated as those spring tides. Now, a great way to remember your tides, a great way to study for these, put diagrams on note cards. Do your eclipses on note cards. Do your tides on note cards. Do all your phases on note cards. Really easy way to try to remember them and study them.